Welcome to the Astro. In this Python tutorial on Astropy package, we are going to see that how to perform sigma clipping on one-dimensional data. So the sigma clipping is used to remove outliers or noise in a data. Suppose you have a huge spread in your data, so you can remove your outliers that affect the result of your data, and you can also estimate the background of an 2D image using this technique. So let's do it. Alright. Okay, so here the sigma meaning that you have a data set, and like data set has a mean, so and mean and a sigma. So the data set evolve the in sigma, so where mean plus n into sigma and min minus n into sigma, the data is going to remove from your clip data, right? So see how it will do, then we'll get a better idea of that. So first I will import libraries. So import libraries. So I will import numpy and Astropy. So import numpy as np. So this will take care of your array, and from Astropy dot stats import sigma clip, right? This will take care of the sigma clipping. Now define your data, right? So define your 1D data. So I will define data equal to np dot array, and I can define say 1 2 5 6 99 105, then 6 9 8. Okay, so what is mistake? There is a double comma. Okay, so we have the data here, right? So we have a data here, and you can also check the mean of the data. So np dot mean of the data. So dot now, so mean is 26 point this much. Okay, so now we'll perform the sigma clipping. So by default it will perform the 3 sigma clipping. So what we can change? So perform sigma clipping, right? Sigma clipping. So basically perform 3 sigma clipping, right? 3 sigma clipping by default. So you can type here clipped data equal to sigma clip, and you can pass here. First of all, you can pass your data, and 3 sigma is default, right? So I will give here data, and sigma is 3 is my default, right? So sigma either give or not, it doesn't matter. So let's return the data, right? So clip data. Okay, so here you can see that nothing has returned. Okay, so because like your 3 sigma is not coming in that. So let's do it. So let's make this as 0. Now check it. Okay, so here you can see that you have like false and true. So there is like one data has been clipped. Okay, so it's 1 2 3 4 5. So your 99 data point, I mean this data is masked. Okay, so this has not been included in the clip data, so this has been outlier. So this has been treated as an outlier in your data points, right? So this way you can do the Okay, so if you give return bounds equal to true, then it will give the lower and the higher point. I mean below which and above which your datas are clipped. Okay, so the lower is minus 3.73 and higher is 4.73. So the only value that coming is 99. Okay, so you can clip that data point. So this way you can do the sigma clipping, right? You can also give here say lower and higher value of sigma clipping, right? So here you can give it sigma lower, say 2 and 3 you can also give, right? So you can give here sigma lower. So I could put here say sigma lower 2 and then sigma upper equal to 3. Let's run it. So this time you can see it has changed little bit. So I will just put now you can extract your clip data and your unclipped data, okay, from the returning array of sigma clipping. Okay, so here we'll extract clipped data, okay, clipped data points. So for that, or clip data, or just call it array outlier, right? Outliers. So just give a parameter called outlier. Outliers equal to your clipped data dot give attribute as a data and give clipped data dot mask. Okay, so run it. So showing here, so tuple object has no attribute data. So basically this array is returning tuple, so we need to remove this. So make it false for time being, right? Now it's fine. So outliers. So here you can see that your data value 99 has been act as a outlier or noise in the data. Okay, so this data is not returning in that, so it is a true, I mean it is a noise in that data. Okay, now we can also open the valid data point. So valid data points. So for that just you need to subtract, or maybe you can just not clipped mask you can say. So just valid data. So we just copy this code and just put here not this command and it will return. Okay, so you can see your 99 is not coming in the valid array. So this is your new array after sigma clipping, right? So this way you can do, and I hope this tutorial is helpful to get insight about what is sigma clipping. So in this we have performed three sigma clipping. You can change the value of the sigma from here, right? So I put here 3, and you can change as per your need and your accuracy. So this is what I have done. So you can review the code once again. You have built some libraries, define a 1D array, done 3 sigma clipping and the data. Then I have extracted the outliers and the by data points. Thank you.